Translation of the graph of the sine wave is given by sine of x minus h plus k. This includes shifting both up and down and left and right. Consider f of x equals sine x in two translations. G of x equals sine of x minus pi over 2 plus 3, and h of x equals sine of x plus pi over 4 minus 2. The graph g of x is the result when sine moves right pi over 2 units and up 3 units. So you can see how it's moved to the right and up, and then we get the blue graph. The graph h of x is the result when sine x moves left pi over 4 units and down 2 units. So if we take any point on the sine wave, move it to the left pi over 4 units and then down 2 units. Use the function f of x equals cosine x for each problem below. Write a rule or formula for the new function g after the given translation. Shift the blue graph left or right and up or down as described. So we're going to start with right pi and up 1. So we start right there where this is just the cosine x wave. Right pi, so we go right pi and then up 1. So there is our new graph. The equation for this new graph is cosine of x minus pi, because we moved to the right pi, and up 1. Next we have left negative pi over 2 and down 2. So let's start back at cosine x. Alright, so left pi over 2, so pi over 2, and then down 2. 1, 2. Here is our new graph. Here's the new equation, cosine of x plus pi over 2, because we move to the left pi over 2, and then minus 2, we go down 2. Next we have left pi over 2 and up 2. So we start at cosine x, then we move to the left pi over 2, and then up 2. 1, 2. This is our new graph. Here's our new equation. We have cosine of x plus pi over 2, so we've moved to the left pi over 2, and then up 2. Next, we have right pi over 4 and down 1. So we always start back at cosine x. We move to the right pi over 4, so that's half of a box, and then down 1. So there is our new graph. And the new equation is cosine of x minus pi over 4, because we move to the right pi over 4, and then down 1. So we have this minus 1 there. The 4x2 grid looks like an ice cube tray. Move the 4 pieces from the left to fill 4 small rectangles in the grid to create these two functions. We're going to start out with a sine wave. So let's draw in our basic sine wave. Alright, so this is sine x. We want sine x minus pi over 2. So we're going to move the whole thing to the right pi over 2, which is one rectangle. So that moves to the right, to the right, to the right, and to the right. And then this piece can just get put on the front there. Then plus 1. So we move each piece up 1 box. Alright, so here is our function sine of x minus pi over 2 plus 1. Next we're going to do a cosine wave. So we have this piece going there, and that goes there, that goes there, and that goes there. This is cosine x. We want cosine x plus pi, so we're going to move to the left pi, which is 2 boxes. So those move there. Alright, and then these can actually move to the side over here. Alright, so now we have cosine x plus pi, but now we need minus 2. So 1, 2, 1, 2, 1, 2, and 1, 2. There we go. Cosine of x plus pi minus 2. Once again, here we have sine of x minus pi over 2 plus 1. And here we have cosine of x plus pi minus 2. Let f of x equal sine x. Its graph is displayed. The function g is given by g of x equals sine of x minus pi over 2 plus 2. Carefully sketch the graph of g of x on the grid below. Label a maximum point on the graph of g. Alright, so all we have to do is just take an individual point and move it. So this point is going to go to the right pi over 2, which is 1 box, and then up 2. So it moves to the right 1, up 2. This point is going to go to the right 1 and then up 2. This point is going to go to the right 1 and then up 2. This point is going to go to the right 1 and then up 2. So here we see the maximums are now up here and the minimums are down here. So we can draw our graph and it looks something like this. I'm not very good at drawing, but our new graph looks something like that. And here we have a much nicer drawing of our g function.